Hello everyone and welcome back to Diksha Karnataka YouTube channel, and today as promised I am here with the KPL 11 solution, and today we have conducted the test at morning. So if you are wondering what are all the chapters that we have covered today, and if you just browsing through it, so let me tell you what are all the chapters that we have covered in today's KPL. First of all, we have covered work, energy, power from your PU1. Then we have system of particles and rotational motion from your PU1 again, and current electricity from your PU2. So these three chapters combined consist 30 questions for KPL 11, and we will be solving all the questions today. And if you have not yet downloaded the question paper, you have to visit our WhatsApp channel. The link is given in the description below, and from there you can download the question paper, solve it, and then you can check the solution. So let's start with the question number 1 for today. The kinetic energy of a body of mass 4 kg and momentum 6 Newton per second will be. So the mass is given and momentum is given. Then they have asked you to find the kinetic energy. We know that momentum can be represented using the formula 2m ek, or if you square both sides, then you can write p square by 2m equals to kinetic energy ek. Okay, so you can find the kinetic energy directly using the formula, and momentum is given 6 Newton per second, so 6 square divided by 2, mass is given 4 kg, so divided by 4, so 36 divided by 8, right? So 9 by 2 or 4.5 joules. Everything is SI unit, so no constants here, so 4.5 joule, direct answer. Okay, now let's move on to the next question. I have solved this question while doing the classwork. Let's try this question again. The relationship between the force and the position of x of a body as shown in the given figure. The work done in displacing the body from x equals to 1. So here they have mentioned that x equals to 1 till x equals to 5. So you have to calculate the work done from moving it from here to here. Okay, during my class work I have done this from x equals to 0 to 5. Okay, so in the question it was still mentioned x equal to 1 to 5, so I made a mistake there, but now I am here to correct the mistake. If you have just copied from our class work, then you have made this is a wrong solution, right? So it should be x equals to 1 till x equals to 5, right? So this is the total work done. So work done is basically area under the curve. If it is above x-axis, it will be positive. If it is below x-axis, it will be negative. So this is negative, right? And this is again positive. So we just need to calculate the total area and then add them. So what is the total area? This is a square of sides 1 unit, 1 to 2 is 1 unit, and from here to here it is 10 unit, right? So the area should be, the work done is given by first area is 1 times 10. Okay, the next area, if you are smart, you should see that this area is positive and this area is negative, so they will simply cancel each other. So we don't need to calculate any of these two areas. Okay, this will be positive, this will be negative. So if it is, this is positive x, this will be negative x. So we are completely ignoring that. We are next calculating the area of this triangle. What is this triangle is? This triangle is half base. Base is, so half base is 1 and height is 10, so it will be 5. So 10 plus 5, it will be 15 joules. 15 joules is the work done, so correct answer will be 15 joules. If they ask you find the power and they give you some time, say this happens in we know that this happens from 1 second to 5 seconds, calculate the power in this case. So power delivered in this case will be 15 divided by 4, right? So 4 seconds is the time delivered and the work done during that time is 15 joules. So they might ask you calculate the power as well. So you can calculate power from this graph as well. Now a force of 10 Newton displaces an object by 10 meter. Okay, so 10 Newton force displaces the object by 10 meter. If the work done is 50 joules, then the angle made by the direction of force with the direction of displacement. We know that work done is basically Fs cos theta. So work done is given 50 joules, force given 10 Newton, displacement 10 meters, and you are supposed to find the value of theta. Right? So cos theta here will be equals to 50 divided by 10 times 10 is 100. So it will be 1 by 2. Right? So cos theta is 1 by 2. Now if cos theta is 1 by 2, then what is the value of theta? So value of theta should be equals to 60 degrees. Right? So I hope you remember the cos table. Now next. A falling body strikes the floor with a speed of 2 meter per second and rebounds with the speed of 1 meter per second. Okay, the loss of energy is. So initial energy, what is the initial energy? And what energy it has? So it is only, the thing is there is a ground here, the ball is coming here and then it is going up. Okay, and only during this time we are trying to calculate how much energy is lost. So there is no potential energy, only energy of the system is completely kinetic energy, right? So what is the initial kinetic energy? Kinetic energy formula, we know that half mv square. Initial speed was 2 meter per second. Okay, so half m 2 meters square. Right? So this is the initial kinetic energy, that is half m times 4. What is the final kinetic energy? Final kinetic energy, again total energy will be kinetic energy in case of final case as well, because it is just about to rise, so there is no height of the object. So again total energy will be half m v f square. What is final kinetic energy? Final kinetic energy is again 1. Right? So final kinetic energy will be again 1, and if you put that you will get half m times 1. Right? Now what is the change in the kinetic energy or change in the energy? Change in the energy is simply delta E, that is EI minus EF. Right? So this is the change in the energy. Now in the answer, if you see, all the options are given in terms of percentage. So how to calculate the percentage change? To calculate the percentage change, you have to divide it with the initial value of energy and then multiply with 100 and add 1% sign. This is the formula, right? To calculate change in percentage in any case. Okay, I hope you have learned that in your previous class of arithmetic, where you are calculating the change in percentage. Okay, initial minus final divided by initial. Okay, or final minus initial divided by initial. Initial will be always in the denominator, the change will be in the numerator. So initially it was half m 4, finally it is half m 1, right? So half m will be common, so it will be 4 minus 1. That is the first case. Now what is initial? That directly write the initial, the denominator half m times 4. So half m cancels, so it will be 3 by 4 times 100%. This is the change, right? So it will be 25, it will be 325 is a 75%. Okay, 75% change. 75% change in the kinetic energy, or the loss of the energy. Okay, two bodies of masses m and 4m are moving with equal kinetic energy. The ratio of their linear momentum is. So two bodies having same kinetic energy, we are trying to find their ratio of their linear momentum. So P1, suppose the first object, two objects are moving, one object 1 and object 2. Okay, both of them has same kinetic energy Ek. Okay, this has a mass m, this has a mass 4m. Suppose the potential momentum of this is P1, momentum of this is P2. Okay. Now we know that momentum and kinetic energy is related by the formula square root of 2m Ek, right? This is for P1. P1 has a mass m. What is the mass of P2? P2 has a mass 4m. So P2 will be square root of 2 4m times Ek. Right? Now they are asked you to find the ratio of these two momentums, P1 divided by P2. Right? So square root of 2m Ek divided by square root of 2 4m Ek. So Ek cancels, 2 cancels. So what is left? Square root of m by square root of 4m. Or we can write this as square root of m divided by square root of 4 is 2 root m. Root m cancels, so you get 1 by 2. Be careful, I have seen students, they cancel this and write answer is 2. Okay, they cancel it, then they forget that there is this 2 is in denominator. Okay, if you are laughing, then you should be careful. Some of you are laughing when I said that student cancel this and write this as 2, but this is very true. Okay, maybe you are one of them who cancels this and write this as 2. So P1 by P2 will be equals to half. Okay, so it will be 1:2. 1:2. Be careful. Okay, sometimes they will give you 2:1 and you might be thinking, okay, have I done it correct order or not? So be careful, solve it in correct order and check the answer after that. Okay, half is 1:2, right? I hope you know that. Now question number 6. A particle moves with a velocity v equals to 3I minus 4j plus 2k. Okay, meter per second under the influence of a constant force F equals to 8I plus 2j plus 6k Newton. It will be in newtons. Okay, the instantaneous power applied to the particle. What is the instantaneous power applied? Power is nothing but force dot velocity, right? Work done is force times displacement, F dot S. In case of power, it is F dot V. Okay, so let's do that, and dot product is easy. Dot product is, first we take what is first term, I cap. Okay, so I cap times I cap. What is the coefficient? 3. What is the coefficient? 8. 3 8 is the 24. We simply write that along with the sign. Okay, so I cap part is done. Next is J cap. What is J cap? Here we have minus 4. Here we have 2. So minus 4 times 2 is minus 8. So I am writing minus 8. Okay, next is K cap. K cap is last. So what is with K cap? 2 here and 6 here. 2 6 are 12. Simple as that. Is it difficult? No, right? So you have to just simply do this and find the answer to be 28. This is the power delivered. Now power is generally denoted by capital P, whereas momentum is denoted by small p, right? So in case you have any confusion about power and momentum, that is also cleared. So 28 watt. Watt is the unit of power. So correct answer is 28 watt. Now next question. When a bob of a simple pendulum swings, the work done by the tension of the string. So when a bob of a simple pendulum swings, suppose it came here once, then it again comes here once, right? So there is a tension force in this direction, always tension along the string, right? So there is a tension force and object is moving in this direction. So what is this angle? What is this angle? This angle is 90 degrees. So 90 degrees means work done by the tension will always be equals to 0. Fs cos theta. Theta is 90 degrees. That means work done will be always 0. Right? Simple question. Just you have to understand the meaning of the question and then you can answer such questions. Question number 8. if the kinetic energy of a body is increased by 300%, then the percentage increase in its momentum will be. So kinetic energy of the body is increased by 300%. So increased by 300% means, suppose initial kinetic energy was Ek. Okay, now the final kinetic energy will be, it is initial kinetic energy, final kinetic energy will be 4 Ek. Why so? It is increased by this much amount. Okay, so difference divided by initial, I told you how to calculate the increase. Okay, this is the amount of increase. So final will be, always remember, final is always, if it is 300%, whatever is the percentage value given, divided by 100 plus 1, this is the final value. You should remember, this is a trick from mathematics. This is not a physics trick, this is a mathematics trick that you may need to remember sometimes. Okay, if it is increased by 20%, so what is the final value? Final value will be 1.2. right? If it is increased by 50%, final value will be 1.5. right? So this is the thing that you have to remember. So final value, initial momentum, what was initial momentum? Initial momentum was square root of 2m Ek, right? What is the final momentum? Final momentum is PF is square root of 2m 4 Ek. Okay, or we can write, we can take this 4 out and we can write square root of 2m Ek. Right? This is the final momentum. Now, so basically we have only taken this 4 outside. Rest of the terms we kept it inside because it is very similar to that of Pi. So when you are doing the steps, you have to understand why we are doing this in such this way. Right? So what is the change in the percentage change we are calculating, right? Percentage change in the momentum. Percentage change in the momentum is final value here 2 root 2mk. Sorry. So if you see 2m Ek is constant, right? It is here also, it is here also. So we are subtracting this from this, right? So it will be 2 minus 1 divided by initial value. Initial value is square root of 2m Ek. So they will cancel. So it is only 1. Change in momentum is only 1, and percentage wise you have to multiply it with 100%. So it will be 100%. So percentage change in the momentum will be 100%. So even though you have changed the kinetic energy by 300%, the percentage change in momentum will be only 100%. And this is a very careful, be careful while solving such questions. This question does not require much physics except this formula. It is mostly based on the concept of percentage. Okay, what is the meaning of increased percentage, what is the meaning of decreased percentage, etc. Right? So this is based mostly on mathematics and not so much on physics. If you know this formula and if you know the percentage relation for if you know the formula and the concept of percentage, you can solve this question. Now let's move on to the next question. A particle of mass 100 gram is thrown vertically upwards with a speed of 5 meters per second. Okay, the work done by the force of the gravity during the time the particle goes up. So you are throwing object upward direction, right? With it has a mass, it has some speed, and it is going up. Now during that time, what is the direction of force? The force acting on this is mg, acting downward, right? So the force is downward, object, the displacement of the object is upward, right? So displacement is upward but force is acting downward, so the work done by this force will definitely be negative. Okay, so it is opposite direction to the applied force, so it will be negative work. Right, as we know that when you lift an object from ground to some height, the work done by us is basically negative. or sorry, work done by the gravity is basically negative. So gravity, when the object is moving up, work done by the gravity is always negative. So now what is the work done in this case? We will use the work energy theorem, where we can say that the kinetic energy, whatever was the initial kinetic energy, that will be converted into work. So kinetic energy will be the work done. What is the kinetic energy? Half, that will be a negative sign. Mass is 100 grams. 100 grams means 100 divided by 1000 kilograms, right? Or you can write 0.1, whatever you are comfortable with. I am comfortable by dividing by 1000 because most students find it easy to calculate like this way. 5 meter per second square, so it is already given in our desired unit. Okay, so let's cancel zeros. So it will be minus 5 5s are 25 divided by 20. Okay, 2 here, 10 here, so it will be 20. So you can say this will be minus 1.25. okay, so minus 1.25 joule is the work done by gravity when it is going up, right? So here the work done is negative. That means the work done by the gravity is stored as potential energy. The meaning of negative work done is that it is stored as potential energy, right? Now next question. A uniform chain has a mass m and length l. We have solved this similar question from your previous question, but that case the length and mass was given in numerical values. It is given in terms of abstract values. Okay, that is the only difference. Otherwise same problem. Okay, a uniform chain has a mass m and length l. It is held on a frictionless table with 1/6 of its length hang over the edge. So we have a table here. Okay, and the chain is like this. If entire length of the chain is L, then 1/6 L is hanging. So it will be 1/6 of L. Okay, so this is considered, this is a small letter L. So 1/6 of L is hanging, and they asked you that the work done in just pulling the hanging part back to the table. How much work you have to do if you just want to pull the chain back to the table, right? So this is a frictionless table, so you just pulling it backwards and the chain is going up. So what we have to do? First of all, you have to determine the potential energy of the system, potential energy of the hanging part especially. If we can calculate the potential energy of the hanging part, the same amount of work we have to do to lift it up. And as you see, the chain is hanging, so potential energy by magnitude will be negative. The symbol of the potential energy will be negative, but we will consider this to be positive value. We will just consider the magnitude. So how to calculate the potential energy in this case? So as I said, we have to use the concept of center of mass. If the object is uniform, the center of mass is located at the center of the uniform object. So you can just consider this hanging part, and its center of mass will be located at the middle. So what is this height? This is 1/6 L, right? So 1/6 of the length is hanging, so this is 1/6 L, so it will be half of that 1/6 L. Okay, so this is the point, and this will be 1/12 L. Here you can consider that all the mass of this wire is concentrated, so you can consider that this is to be a point mass, and how much work you want to do to lift this object from here to here. Basically that is the thing you are doing, right? Now how to calculate the mass of this portion? So total mass for length L, the mass is m. Okay, so total mass is m for length L, right? Small m. Now how much part is hanging? Hanging part is 1/6 of L. This much part is hanging. So what is the mass of this hanging part? So it will be m divided by L times 1/6 of L. So L cancels, so the mass will be m by 6. This is the mass of this piece. This is the mass of this piece. So now you can consider that entire mass is located at this point. So m/6 mass is located here, okay, and the height of that from the table is 1/12 L. So how much work you have to do to lift it from here to here? So what is the potential energy? Potential energy in this case, mgh. It will be obviously negative because it is hanging below, but here the m is m/6, g will be g, and h is this height, 1/12 L. Okay, do not use 1/6 L in this case, then you will make a mistake. Okay, so mgl divided by 72. So mgl divided by 72 should be the work done to pull that wire back to the table. So this is a simple version problem. In JEE Mains and JEE Advanced, there are difficult level of the same version of the question comes, okay, and that is not easy question. Okay, this is an easy question. You can just simply find how much, what is the center of mass, position of the center of mass, how much is the mass, and then mgh. That's simple, right? But in JEE level, advanced level questions and JEE Mains level question, this question comes a little bit complicated. There will be a velocity involved, there will be friction involved, right? Now let's move on to the next part. Here it is system of particles and rotational motion part. From question number 11 to question number 20 is system of particles and rotational motion chapter questions. So first, two bodies of mass 6 kg and 4 kg have position vectors 5i plus 2j plus 10k, right, and 10i plus 2j plus 5k. The position vector of the center of mass of this system is. So what is the meaning of that? We have two mass, and in the coordinate system x, y, z, say this is x, this is y, this is z, okay, x, y, z. Now you have point, say one mass is here, okay, and the coordinate of this, we know that position vector can be written as coordinates, right? So if the coordinate of a point is x comma y comma z, then the position vector of this point can be written as xi cap plus y j cap plus z k cap, right? Now similarly, if the position vector is given, we can instantly convert it into a coordinate. So coordinate of this point is 5, 2, 10, right? This is the m1. So what is the m2? M2 is located somewhere else in the same direction, same coordinate system. So this is m2, and its coordinate is 10, 2, 5, right? So this is the coordinate of the second point. Now what they have asked you, find the center of mass. Center of mass will be somewhere in the middle, okay? So this is suppose cm. You have to find the coordinate for this cm. How to find the coordinate for cm? We know that xcm is equal to sum of mi xi divided by total mass, right? What is the meaning of that? For first mass, we will multiply the mass. What is the value of the first mass? First mass is 6 kg, right? So this is 6 kg, this is 4 kg. So first, how to calculate xcm? We will calculate first mi. Mi is, first is m1, m1 x1. So 5, 6 is m1, 5 is x1. Plus some symbol is there, so it will be plus m2 x2. What is m2? M2 is 4, x2 is 10. So m2 x2 divided by total mass. Total mass is m1 plus m2, right? So calculate this value. 5 6 are 30 plus 40 divided by 10. So 70 by 10 is 7. Right now, if you see, there are two options with 7. So you have to calculate the second value as well. What is the second value? YCM. Now there is a trick. you have found out that both option B and option D has same first answer and same second answer as well. So don't calculate YCM. Okay, you have calculated that out of these two options will be one of them will be correct. Right? Which one will be correct? If you see the first one and second one are correct, is equal for both the cases. So if you calculate the second one, you will get 2. Because your first calculation is correct, then both of them has 7. If you will get the second value will be 2 as well. But if you see there is a difference in the third value. So in that case, instead of calculate YCM, you have to calculate ZCM. That will be a faster process to find the answer. So these are the small tricks that you need to learn while solving this kind of questions based on the options. Right, this is the smart calculation. So what is ZCM? How to calculate ZCM? M1 Z1, M1 Z1, this is Z coordinate, right? So M1 Z1, M1 is 6, Z1 is 10 plus M2 Z2, this is M2, this is Z2. So M2 Z2 divided by M1 plus M2, that is 10. We already know that. So it will be 60 plus 4 5s are 20 by 10. So it will be 80 by 10 or it will be 8. Right? So correct answer will be this one. Right? So when we did the same problem in our classwork, the options was given such a way that you can easily find the answer only after calculating XCM. But here during the mock test, I have given the options such that you have to at least calculate 2 values. And if you are not smart enough, then you have to calculate all 3 values. If you are smart enough, you can answer them like XCM, skip YCM, because YCM is same in both cases. So you calculate ZCM, which is different. Right? Now, question number 12. A shell fired from a gun at an angle to the horizontal explodes in the midair. Then the center of mass of the shell fragment will. So there was a shell, it was moving in the parabolic path. Somewhere in the path here it explodes. So what will happen to the center of mass? So when the shell was going in this direction, the center of mass was also moving in this direction. Right? Now we know that center of mass will continue to move with the same velocity in all direction. Right? It will have the same whatever component of velocity it has at this direction and whatever component of velocity it has in that point of time. Then there will be gravitational acceleration. So it will continue to follow that parabolic path. It will continue to follow the parabolic path. Move along the same parabolic path along which it was exploded shell was moving. Okay, that is the conservation of momentum principle for system of center of mass. Sorry. So center of mass will continue to move in the parabolic path as if the shell was not exploded. So basically what does that mean? So one piece will go in this direction, then other piece will go in this direction, so that the resultant momentum will be along this parabolic path. That is the basic meaning. If you understand the basic meaning, then this kind of problems becomes easy. Now, question number 13. A gymnast sitting on a rotating stool with his arm outstretched. So, he was sitting on a gymnastic tool. If you have seen gymnastics, they rotate in a special kind of tool and he is sitting like both arms stretched. Right? Suddenly lowers his arm. So, suddenly he was rotating and his hands was like that, and suddenly he lowers his arm. So, what will happen to the angular velocity? That is the basic question. So if you know that when the gymnast was rotating like this, okay, his moment of inertia was very high. We know that moment of inertia is mr square. So m is fixed, r was more in this case because the circle that he was completing was more. Right? As soon as he contracted his hands, the r becomes less. Now r is only this one hand of a distance. Right? So r decreases. So moment of inertia decreases. Now angular momentum, we know that angular momentum is I omega. I1 omega 1 should be equals to I2 omega 2. Initially I1 was very large, okay, so omega 1 was very small value. Now I2 is now smaller, so omega 2 has to be bigger to compensate that, right? So angular momentum, from the conservation of angular momentum, we can say that the angular velocity will increase. Okay, so angular velocity increases. Okay, moment of inertia decreases, right? Moment of inertia decreases. They have not given any other option. Angular momentum is constant. Okay, angular velocity will only increase. If they asked you angular moment of inertia decreases, that would have also been a correct answer. Okay, interesting question. Question number 14. The angular speed of a motor wheel is increased from 1200 rpm to 3120 rpm in 16 seconds. The angular acceleration of the motor wheel is. So I solved this question during the class. First you have to calculate the delta omega. What is the change in the angular velocity in terms of rpm? What is rpm? Anyone? If you know before I answered it, please mention in the comment below now. Okay, once I answered it, then there is no point of writing after listening to me, right? RPM is rotation per minute or revolution per minute. Okay, so now what we have to do, we have calculated the change in angular speed in terms of RPM. Okay, not RMP, RPM. Now we know that angular acceleration or acceleration is basically change in velocity by time, right? So angular acceleration is change in angular velocity by time. But if you see, the answer is given in radian per second square. So what we have to do, we have to convert RPM into radian per second first. So how to convert RPM to radian per second? There is a shortcut formula, 1920 times 2 pi by 60. This is the conversion formula from RPM to radian per second. 0 cancels, 3 8s are 18, 3 2s are 12, there is a 2 pi, 32 times 2 pi is 64 pi. Okay, so 64 pi is the delta omega, and time is given in seconds already. If it was not in seconds, if it was in minutes, then you have to convert it into seconds first, right? So 4 16s are 64, so the correct answer is 4 pi. Be careful while solving numerical problems, especially with the values. Okay, you are not allowed to use calculators, so stop using calculators. If you are still using calculators for your day-to-day calculations, stop using that. If you stop using calculators, then only your analytical things will improve. Now question number 15. Two particles which are initially at rest move towards each other under the action of their mutual attraction. If their speeds are v and 2v at any instant, then the speed of center of mass of the system is. So first of all, two particles, they were initially at rest. So the particles were initially at rest. Now what we learned? We learned that if the particle is initially at rest, the center of mass was also at rest. Even after the particles started moving towards each other, due to their mutual attraction, no external force is acting. So no external force is acting means the total momentum of the system will be conserved. The momentum of the center of mass will be conserved. So initial speed of the center of mass was 0. The final speed should also be 0. Center of mass is only 1 point. Okay, if it was, you cannot break center of mass into two different points. Center of mass will always remain 1 point, and if the system initially was at rest, it will continue to stay at rest. That is the beauty. Okay, if it was moving in a constant velocity, okay, center of mass will continue to remain in the constant velocity even after maybe it collided with something, and total system of mass, center of mass will remain in the same direction. Similarly, if it is breakdown like a bomb, okay, the shell that example that we have learned, a rocket, okay, in that case the center of mass will continue to stay in the same course, okay, even though the individual particles are deviating. Question number 16. Two balls are thrown simultaneously in air. Okay, the acceleration of the center of mass of the two balls when in air. So two balls are thrown in the air. The center of mass is somewhere here. What is the acceleration of the center of mass? Acceleration of the center of mass is simply g, does not matter, right? The center of mass, the acceleration of the center of mass is equals to g. Okay, it does not depend on masses, it does not depend on the direction of the two balls. Okay, depends the speed of the, no, does not depend on the speed of the balls. It is constant, it is only being attracted by the force of gravity. So acceleration is equals to g. Which of the points likely the position of the center of mass of the system in the shown figure? In this shown figure, there is a air here, there is sand here. Who is heavier? Air is heavier or sand is heavier? Obviously sand is heavier, that's why sand lies on the ground, air stays in the atmosphere, right? So when two objects, one heavy, one lighter, are kept together, then the center of mass is closer to the heavier object, and maybe in some cases it is even within the heavier object. So in this case we can see that only case where center of mass within the heavier object is D. So correct answer is option, correct answer is point D. Correct answer is point D. Option should be D. Sorry, option should be B. So because in option B point D is mentioned. So students will get excited and they mark option D as correct answer. Okay, don't get excited too much. First read the question, check if you have correctly understood the question, and then if you have marked the question correctly, then only mark it in the OMR sheet. Okay, OMR sheet is very important. Those who are preparing for KCET exam, student will get excited. Okay, D, I will mark D. Right? Don't do it. Question number 18. Moment of inertia of a thin uniform rod rotating about the perpendicular axis passing through its center is I. Okay, so moment of inertia of a thin uniform rod. So moment of inertia of a thin uniform rod about a perpendicular passing through its axis is I. So what is the value of I? I is 1 by 12 ml square, where L is the length, right? L is the length of the rod, right? If the same rod is bent into a ring, now what you have done, you have taken this rod and you have bent it into a ring. Okay, bent into a ring, the moment of inertia about its diameter is I dash. Okay, so then what is the ratio of I by I dash? Now what is the common here? The same rod is bent into a ring. Okay, so in this case the length of the rod should be equals to the perimeter of the ring, right? So length of the rod is L, perimeter of the ring, suppose the radius is R, then perimeter will be 2 pi r, right? And that perimeter should be equals to the length of the rod, right? And what is the moment of inertia in this case? Moment of inertia in this case will be half m r square. So what we have to do, we have to calculate the ratio of I by I dash. So they have asked you to find the ratio I by I dash. So let's calculate. I is this is 1 by 12, sorry, I is 1 by 12 mr square, right? Not half ml square. Okay, that is special for a rod. For rod it is 1 by 12 ml square. And since it is bent, in the same rod is bent, so mass should remain same. Okay, only thing is the radius will be different. So m cancels. So 2 by 12, this 2 will go up. Okay, 2 by 12. Okay, L square. What is L? L is 2r, 2 pi r. So put the value 2 pi r whole square divided by r square. So if you see, only r square is left here. M already cancelled. This 2 goes up. So it will become 1 by 6. So 1 by 6 times this r square and this r square will cancel. right? This r will come out of the square and it will cancel. So 2 pi whole square, 2 pi whole square means 4 pi square. 2 pi whole square is 4 pi square. So you can cancel this further. 3 to the 6, 2 to the 4. So the answer will be 2 pi square by 3. Right? So 2 pi square by 3 should be the answer. So option is option D. If you have any doubt regarding this, please don't forget to mention that in the comment below. Question number 19. A force F equals to 5I cap plus 2j cap minus 5k cap acts on a particle whose position vector is r equals to I cap minus 2j cap plus k cap. What is the torque about the origin? So two forces are acting. We know that torque about the origin is given by r cross F. Okay, so torque about the origin is r cross F. So we have to do the vector multiplication. So if two vectors are there, x I cap, x1 I cap plus y1 j cap plus z1 k cap, and another vector, suppose this is vector A and vector B is x2 I cap plus y2 j cap plus z2 k cap, then you can write vector A cross vector B is equals to I cap plus I cap j cap k cap, and then x1 y1 z1 x2 y2 z2, right? So this is determinant, the same determinant that you learn in mathematics. Okay, this is on nothing different. You can do the same operations that you do in mathematics. Only thing is that these are constant, so you have to keep them outside bracket always, and you just need to do the process. So what is r cross F here? So r cross F is nothing but, first we will write I cap j cap k cap. Now in case some of them are 0, so suppose no j cap is there, then we would have written 0 here in case of j cap. So 5 I cap, so it will be 5, okay, plus 2 j cap, so it will be plus 2, minus 5 k cap, so it will be minus 5, right? Next is first we have to write the r vector. My mistake, extremely sorry, because r cross F, right? So first we have to write the r vector. R vector is I cap. I cap means, what is with I cap? 1. So first we will write 1. Next is minus 2 j cap, so it will be minus 2, okay, and plus k cap. Plus k cap means 1, right? Now write this again, 5 2 minus 5, right? I cap, j cap, k cap. Just write in one after another, right? Now first term I cap. So how to do the calculating the determinant? First we cover the entire top row, right? Then we cover the first row. So this is the corner element, so this is I cap, so this comes first, right? And then we do the cross multiplication. Minus 2 times minus 5, that is 10, minus 2 times 1, that is 2. I cap work is done. Next is j cap. Now tell me in the comment below if you use negative sign here. Okay, there are two ways to calculate for the middle term. Either you can use negative sign or you can use positive sign. Just follow the circle. Okay, so first we did this to here, then we move here, here to here. So my dot is now here. Okay, so now we will cross everything on along the z-axis. So 1, 2, 5. So 5 ones are 5. So 1, 2, 5. Then again we move in this direction. Minus 5 times 1, minus 5 times 1, minus minus plus, so it will be 5 again, right? Next is k cap. K cap is, again we will cover this. My cursor is now in this case 1, 1 2s are 2, minus 2 5s are minus 10, so minus minus plus, it will be plus 10. Okay, plus minus, the way you solve determinant, that is up to you. Okay, how you are solving, I hope you are master of solving determinants by now, right? You are solving too many determinants. So it will be 8 I cap, 10 minus 2 is 8, 5 plus 5 is 10, 10 j cap, 10 plus 2 is 12, k cap. Okay, so 8 I cap plus 10 j cap plus 12 k cap. So correct answer is option B, right? Now next question, question number 20. A body having moment of inertia about its axis of rotation equal to 3 kg meter square. It is rotating with the angular velocity of 3 radian per second, right? So moment of inertia is given by I equals to 3 kg per meter square. Okay, SI unit. It is rotating with the angular velocity of 3 radian per second. Again SI unit. Okay, kinetic energy of this rotating body is same as that of a body of mass 27 kg moving in the velocity v. The value of v is, so we know that for rotating object the kinetic energy is given by half I omega square, and for object moving in linear motion it is half mv square. Now in this case they are equal. Okay, so for this object, first object, rotating object, what is I is 3. Okay, omega is 3 again, so 3 square. Okay, now what is the mass of the object? Linear motion 1 object mass is 27, so half cancels, so 3 times 9 equals to 27 v square. 3 times 9 is 27, so v square equals to 27 divided by 27, that is equals to 1. So v equals to 1 meter per second. So v will be 1 meter per second. Simple question. Now let's move on to some problems from current electricity chapter. Very interesting. First question is very interesting question. I can see from the diagram. Find the equivalent resistance between the terminals A and B in the circuit shown in the figure. So they have asked you to find the equivalent resistance between point A and point B. Okay, so this might look complicated, sir. There is no connection in between C and D. How can we calculate this? Simple thing. So if there is no connection means you can simply ignore this part. This part is irrelevant. So current starting here, it will follow this path, right? No current can go here, and this is like a bridge, but bridge is not completed. Okay, if any current goes here, it will fall, right? So no current will pass through these two resistors. These two resistors are called open resistors. No current will pass through these two resistors. This is a very silly questions to make you fool. That's it. Okay, if you are smart, if you are not fool, you can answer this question. Now let's see the connection. So in this case, as you can see, this point, this point, this point and this point, they are like, you can draw them one by one, right? So they are connected in series. these three resistances, 2 ohm, 2 ohm, 2 ohm, they are all connected in series. Okay, now this series connection is now then again connected in parallel to this 3 ohm. Okay, then again this system is again connected in series. So we will solve them step by step. So step 1, first we will consider this 3 ohm, this one and this one. We always start from the outer side, not from the inner side. That is the main thing. Many students start, okay, these three are in series, these three are in series, they are in parallel. No, you cannot start from outer side. You have to consider only the independent sides first, okay, which are in the outer side, okay, which are not directly connected to AB. That is the first point. So these three are connected in series, 2 ohm, 2 ohm, 2 ohm. So if we replace this with a single resistance, then what will be the equivalent resistance for this part? Obviously it will be 2 plus 2 plus 2. Yes, as easy as that, 2 plus 2. But here it will, you have to add 3 times. 2 plus 2 plus 2. So it will be 6 ohm. This is 3 ohm. Now what is the equivalent resistance of this part? Now this become independent, right? This has no connection to anything else. So now you can consider this to be the outer part. So 3 and 3 ohms are 3 and 6 ohms are connected in parallel. So what is the equivalent resistance? 6 times 3 divided by 6 plus 3. I hope you remember this formula, R1 R2 divided by R1 plus R2 when two resistances are connected in parallel, right? So 18 divided by 9, so basically this is 2 ohm, right? If you forgot this formula, you can revisit my chapter current electricity. There I have discussed in detail. So now this figure will become, this 3 ohms is here now, and this entire thing is 2 ohm. So we just replace it with a single resistance. This is 2 ohm and this is 3 ohm. Okay, so now you consider this is the outer part now, 3 plus 2 plus 3. So this is connected in series. 3 plus 2 is 5, 5 plus 3 is 8. So the equivalent resistance is 8 ohm. Okay, so correct answer is option A, 8 ohm. Be careful, simple question, just follow the steps. I have elaborated the steps, so that's why it took some longer time, but if you do it methodically, you can solve it in less than 1 minute. So now let's move on to the next question. Question number 22. Potential difference between the point P and Q in the electric circuit shown is. So you have to calculate the potential difference between the point P and Q. This is also interesting question. Okay, you might think that this is a Wheatstone bridge principle. Okay, so potential difference might be, you might think, okay, they may be 0. Actually not. So in Wheatstone bridge principle, see, that connection was different. That connection was done from this side, right? And there is no current, no point here. So that is the thing. They given you something else that looks like Wheatstone bridge, right? So it is not a Wheatstone bridge. So how can we find the potential difference? To calculate potential difference, we know that Ohm's law, V is equal to IR. Okay, I is already given here. If you can calculate the equivalent resistance, then you can calculate the potential difference. Simple. So how can we calculate the equivalent resistance? So for that you have to see which of the parts are independent here. So if you see, this part is not connected to anything else. You can see that they are connected in series. So 3 ohms and 4 ohms are connected in series. Again, similarly, you see that 6 ohm and 8 ohm are connected in series. So these three are again now in parallel, right? So first we have to write this resistance, 3 plus 4, which is 7. So there is a 7 ohm resistance, okay, which is connected like this. Next is this one. This one is single resistance, okay, and again these two connected in series. So 6 plus 8 is 14. So these three resistances are now connected in parallel, right? So they are connected in parallel. So how can we calculate the equivalent resistance? 1 by R eq. Very, very careful. Okay, three resistances, you cannot apply the law that formula that I taught you. So what you have to do, you have to apply this method. So 1 by 7 plus 1 by 2 plus 1 by 14, right? So what is the LCM? LCM is obviously 14. Okay, 7 2s are 14, 7 2s are 14, 14 1s are 14. Okay, so it will be 2 7s are 2 plus 7 is 9, 9 plus 1 is 10, so 10 by 14. Okay, so R equivalent is 1.4. It is inverse of that, so 1.4. So next you have to calculate the potential. What is the formula for potential? I already told you, V is equal to IR, and current is given here is 15, and R we have calculated 1.4 ohms, right? So 15 ones are 15, and 0.4 times 15 is 6. Okay, how to calculate 0.4 times 15? First remove the point. Imagine 4 15s are. 4 15s are is 60. So if you add that point back in now, then it will be 6. So you can do this. First you multiply with 1. So 1 times 15 is 15. 0.4 times 15 is 6. So this is another way of smart calculations. So V is equal to 21 volts. Okay, so it will be 21 volts. Now next question. A 5 ampere current is set up in an external circuit by a 6 volt storage battery for 6 minutes. Okay, the chemical energy of the battery is reduced by. So this is the ampere current, this is the voltage, okay, and this is the time. And they asked you to find the chemical energy of the battery is reduced by how much joules or volt. How can we calculate that? So first of all, we know that power, whatever the power is generated, that power will be used for wasting the chemical energy, right? So we know that power is basically VI and energy is VIT. Simple as that. So what is vitamin? I told you vitamin. If you remember, vitamin V is 6 volts, I is 5 amperes, and time is 6 minutes. 6 minutes means 6 times 60 seconds, right? So this is the energy. So now you have to just be careful and multiply it. That's it. 5 6 are 30 times 360. Okay. Okay, so it will be 10800. So or you can write this as 1.08 times 1234. Okay, it will be, its unit will be joules, not volt. Volt is the unit of potential difference, not the work done or not the energy. Okay, so if you want to convert from volt to joule, you have to multiply with the charge coulomb. Okay, so unit will be in joules. So basically the question is such that if you know the unit of energy or not, right? So energy is basically VIT, the energy that is being delivered by the battery. The same amount of energy will be converted from, who will supply this energy? The chemical energy stored in the inside the chemicals, right? So don't get afraid about, oh, the question says the chemical energy etc, maybe it is difficult. No, basic physics is important. Okay, basics of physics is important. If you know the formula, calculate the formula, then you think, okay, maybe inside the battery the same energy that is being provided by the battery is converted, coming from the chemical energy, right? Now next question, calculate the current in the circuit shown. Okay, another interesting question. So here if you see that this is a simple parallel two circuit, two resistors connected in parallel. This has 3 ohms, this has 6 ohms. Current through this is given as 2 amperes. Right, current through this is given as 2 amperes, and they asked you what is this current, I. Basic thing. Now how to do that? So first of all, if this is the current I, and if we can find the equivalent resistance of the system, which is very easy because only 2 resistors in series, okay, I, then what is the voltage drop across this? The voltage drop across this is Req times I, V is equal to IR. This is the voltage drop, right? Now from parallel combination we know that individually both resistances have the same potential drop. So individually this will also have the same potential drop. So what is the voltage drop across this 3 ohm resistance? 2 times 3, that is 6 volt. Okay, 2 multiplied by 3, 2 times 3, VI, RI, right? So that is the voltage across this. The same voltage will be applied across this, but I am not going to use that. You can use Kirchhoff's law as well. I am trying to keep it simple. So how to do that? Find Req. Req is, in this case, 3 times 6 divided by 3 plus 6. 3 times 6 divided by 3 plus 6. So 18 divided by 9. That is 2 ohm. Okay. Now that Req times I should be equals to 6 volts. Right. So 2 times I should be 6, or I should be equals to 6 by 2, that is 3 amperes. So it will be 3 amperes. Simple question. This is a simple question. Only thing that you have to understand it. Don't be afraid of this kind of questions. Next question. The variation of resistance of the conductor with temperature is as shown. The temperature coefficient alpha of the conductor is. So they asked you to find the temperature coefficient of alpha, right? And what all is given? The variation of resistance is given. Slope is given here. Okay, so slope is given here. Okay, this is R0. After some time, suppose its value is R. At this point, suppose the value is R, then what is the change in the resistance? Change in the resistance, that is delta R, is basically and what is the change in the time say delta T. Okay, then what is slope? Slope is basically delta Y by delta X. So in this case, delta Y is delta R and delta X is delta T. Okay, so slope is this, right? Now what is the temperature coefficient? Basically temperature coefficient, we are trying to find the temperature coefficient. Also we need to use the value of R0, right? So suppose after time delta T, the resistance, the new resistance is R, then R0 minus R equals to R0 alpha delta T. This is the basic formula. Sorry, I made a mistake here. Is R minus R0. Right? So R minus R0 is what? R minus R0 is this delta R. So delta R equals to R0 alpha delta T, or alpha equals to delta R divided by R0 delta T. Now what is R by R0? R by R0 is M. So it will be M by R0. So coefficient of temperature coefficient is given by M by R0. M by R0 is the temperature coefficient. Next question. A wire of certain material is stretched slowly by 10%. Okay, so wire of certain material is stretched by 10%. So it is something like this, and now you stretched it. So suppose initially its length was say 1 meter. Now it will be 1.1 meter, right? 10% stretch means like this. Its new resistance and specific resistance becomes respectively. So first of all, you have to remember that the specific resistance does not change by stretching. Okay, it only can change if you heat it. Okay, by temperature you can change the specific resistance. Otherwise, if temperature is constant, the specific resistance or resistivity, okay, specific resistance or resistivity, both are same thing, they remain unchanged. Okay, so specific resistance or resistivity is constant when temperature is constant. So temperature is not changing, you are just stretching it. So in that case, obviously length is increasing, area is decreasing. Okay, you can calculate this question, but there is only one correct option from the combination that you have to identify. You don't need to solve it, okay, because 10% increase means it is not so simple to calculate, it will require some steps. Okay, but if you see that specific resistance will remain constant. Now how many option has specific resistance constant? This one gives constant and only this one gives constant. Okay, here also it is increasing 1.1 times, here also it is increasing. Specific resistance does not change. So that means either of these two option is correct. Now option is, it is like a playing KBC and 50-50, right? Computer G, delete the two incorrect options. So the two incorrect options are already deleted. So now what all are the correct options? Correct option, as you can see, only this one, because resistance will not remain same, resistance will change. So resistance will change and specific resistance will remain constant. So easy to answer, you can do the mathematics, you can find it, but that is for a different day. If you are very good in physics numericals, and if you are preparing for JEE Mains, then you can try to solve this question. Okay, now question number 27. A wire of resistance 3 ohm is stretched to twice its original length. The resistance of the new wire will be. So there was a formula I derived during the class. Let's do that formula once more to solve this question. R is equal to rho L by A, if you remember, right? Now when you are changing the length, okay, changing the length means, does not mean only length is changing. Length increases means area has to decrease. For example, if you take a rubber band and if you stretch it, as the rubber band is stretching, the width of the rubber band is decreasing. So basically area is decreasing. So what is constant in this case? The constant thing is the volume, that is length into area, right? Volume is constant. Volume has to remain constant, the matter inside that has to remain constant. So L into area will remain constant. So initially suppose the length was L1, the area was A1. Okay, now next the length is twice. Twice means new length will be 2L1. You increased it, stretched it, length has become 2L1. Now suppose the new area has become A2. Okay, now what is the relationship between A1 and A2? That is the main question. So A1, L1 cancels, A1 is equal to 2A2, or A2 equals to A1 by 2, right? So initially the resistance suppose was R1. What is the final resistance? Final resistance, say R2, is rho L2 by A2, right? New length is L2, new area is A2, so new resistance will be R2, rho is constant. Now let's put the values from there. So what is the new length? New length is, it is doubled. Doubled means 2L1. A2, we have already calculated A2. So A2 is A1 by 2. Okay, so you can write this as, this 2 will go up So it will be 2 times rho L1 by A1, or you can write this as 2 square rho L1 by A1. What is rho L1 by A1? Rho L1 by A1 is R1. So you can simply write this as 2 square R1. Why I have written this in terms of 2 square? Because in case instead of twice, if it says the length, it is compressed such that its length becomes half, or it is stretched so that its length becomes 4 times, or its length becomes 5 times. So what you have to do in that case, if the length increases, okay, by the times value, so twice, 2 times, twice, thrice, 3 times, 5 times, so that will become here as square. If it is decreased, so halved means 0.5, okay, 1/3, so it will be 1 by 3, so that will come here square as a squared term, okay. And so as you can see in this case, length is twice, so 2 square, and resistance was 3 ohm, so 4 times 3 equals to 12 ohm. Okay, so correct answer is 12 ohm. Okay, so be careful while answering this question. If you remember this formula, you can answer this in one line, okay, in one line, less than 10 seconds. But if you don't remember the formula, then you can use the longer method. Okay, that's why I said the number of times. Okay, so the formula is R2 equals to N square R1. Okay, N is twice, thrice, 5 times, whatever is that value, that is the N. Okay, now next question, 28. A car has a fresh storage battery of EMF 12 volt and internal resistance of 2 times 10 to the power of minus 2 ohms. If the starter motor draws a current of 80 ampere, okay, then the terminal voltage when the starter is on is. So we have a battery, and in this battery there is a 12 volt power supply, EMF basically, and the resistance is 2 times 10 to the power of minus 2. When you connected it to the starter circuit, which is basically resistance, you can consider that it is drawing a current of 80 ampere. So 80 ampere current is being drawn. So what is the terminal voltage? What is the terminal voltage here? That is very simple question. So first of all, what we have to do? We have to find how much voltage is dropped across this circuit, this resistance, this internal resistance. Current is 80 ampere, internal resistance is given. So how much internal voltage drop is happening? Internal voltage drop is happening is I times internal resistance. I is 80, internal resistance is 2 times 10 to the power of minus 2. It will be 160 times 10 to the power of minus 2, or 1.6 volt. So this much voltage is wasted by this internal resistance. So this much voltage is wasted. So how much actual voltage that we are getting? So actual voltage that we are getting is basically epsilon minus VR, okay, or 12 volt minus 1.6, so 10.4 volts. You can use one more formula, that is V is equal to epsilon minus IR. That is also fine. Okay, IR. That is also fine. That is a simple straightforward question, straightforward answer. This question is one of your previous year questions. So this kind of question is very common from this chapter. Now question number 29. Kirchhoff's junction rule is a reflection of Kirchhoff's. There are two rules: Kirchhoff's junction rule and Kirchhoff's loop rule or voltage rule. Okay, so we used to call it Kirchhoff's current law This is basically because it talks about Kirchhoff's current and Kirchhoff's voltage law, where we are talking about voltage. So Kirchhoff's current law or junction rule talks about the conservation of charges. Okay, it talks about the conservation of charges. Kirchhoff's voltage law, on the other hand, or Kirchhoff's loop rule that is given in your book, that talks about the conservation of energy. Okay, these two laws, basically two conservation laws. We have learned two conservation laws: conservation of charges and conservation of energy. Conservation of mass we learned in previous classes, but conservation, we know that mass is individual, is not conserved, it is conserved along with energy. So energy and mass are on the other hand, they are same thing. So conservation of energy for Kirchhoff's voltage law or Kirchhoff's loop rule. Kirchhoff's junction rule is conservation of charges. Next question, question number 30. Another easy question given in a difficult way. Okay, so there is a tendency that questions for KCET comes, easy questions are asked in a difficult way. That is the main thing. If you understand a little bit about the concept, then you can answer this question easily. So what is this question? The effective resistance between P and Q. So effective resistance between P and Q means equivalent resistance. How to solve this? There is a triangle given here, but you take your pen, if you go from here to here, you can see that you can draw them without crossing any other resistor. That means they are connected in series. So these two resistances are connected in series. So what you have to do, you have to add them. 3 plus 3, that is 6. So first part is 3 plus 3, 6 ohm. This 6 ohm is in parallel with this 6 ohm. Okay, then we have this 4 and 5 ohm. One arm has 4 ohm, one arm has 5 ohm. Now, if two equal resistances are connected in parallel, I told you during the class, two equal resistances connected in parallel, then their equivalent resistance will be, when two equal resistances, say capital R and R are connected in parallel, then their equivalent resistance will be R by 2. Right? So this will be the equivalent resistance. So 6 and 6 are connected in parallel. What will be the equivalent resistance? The equivalent resistance will be only 6 by 2, that is 3 ohm. So this entire triangle is basically 3 ohm. Right? Now we have one 4 ohm here and one 5 ohm here. Right? So what is the total resistance? Now you can say they are connected in, how they are connected? Parallel. Is it? They are connected in series. 4 plus 3 is 7, 7 plus 5 is 12. So 12 ohm is the equivalent resistance. So 12 ohm is the equivalent resistance. So we have completed all the KPL of this week's question paper. I took a little bit time to explain you slowly because some of you are saying that, sir, please explain it slowly. So I have started answering the questions, answering the problems slower than previously. I used to do a little bit faster, but since most of you are struggling to understand the questions, so I think also we are at the very important crucial stage of our KPL state. Also, if you are preparing for KCET exam, exam is coming very close to your exam dates will be announced very soon, and that's why I have started solving the questions slowly so you can understand entire question paper. And if you still have any questions, don't forget to mention that in the comment below. Don't forget to share the video with your friends and subscribe to our channel. I'll be back with a new lecture tomorrow. Till then, bye.